This video is about adding and subtracting polynomials. It's lesson 53 in your book on pages 335 through 342. And I think you guys are really going to like this lesson because it really boils down to adding and subtracting like terms. So here are some new concepts that we need to learn. First of all, a monomial means that we have the product of numbers and or variables with whole number exponents. Now, mono is a prefix that means one. So this tells us that we have something with one term. There's no pluses, there's no minuses. It's just the product of a constant and or variables with whole number exponents. Remember, whole numbers are 0, 1, 2, 3, 4, 5, etc. So we're going to decide which of these examples on our paper here are monomials. So remember, our requirement is they can be a constant, they can be a variable, or they can be a constant and a variable with a whole number exponent multiplied. So if we look at this first one on the left here, x, that is the product of 1 and x, or a constant and a variable. And the exponent on x here is a positive 1, which is a whole number. So this one is a monomial. If you look down here, we have 0.75 x to the negative second. Now this is a product of a constant and a variable, which is fine. But notice that the variable has an exponent that is not a whole number. Negative 2 isn't a whole number, it's an integer. So this one would not be a monomial. And that's because it has an integer exponent. Here we have the number 3. Now, a constant can be a monomial as long as it isn't being multiplied by a variable with a whole number or with a negative exponent. So since 3 is just a constant, it is a monomial. Right here we have 2 over x to the third. Now if we were to move this x to the third up into the numerator, it would be 2x to the negative third. That's a product of a constant and a variable with an integer exponent, but not a whole number. So this one is not a monomial. Right here we have 1 over x. If we were to move that x into the numerator, it'd be 1x to the negative first, because in the denominator it's positive, so when we move it to the top it becomes negative. And since that variable has a negative exponent or a non-whole number exponent, that one's not a monomial either. Right here, we've got negative xy. Now that's the product of negative 1 times x to the first times y to the first. Since we have constants and variables and all the exponents on our variables are whole numbers, that one is a monomial. For some reason, we've got 3 over here again, and 3 is, as we've already said, a monomial. Right here we have x minus y. Now remember before I said in order for it to be a monomial, it had to have only one term. But this has 2 terms, an x and a y separated by a subtraction sign. So that one is not a monomial because it doesn't have just one term. Here we've got 0.75x squared. It's the product of a constant, 0.75, and a variable x with a whole number exponent, 2. So that one is a monomial. And right here we've got x cubed over 2. Now if I was to move that 2 so that it was in my numerator, sort of, I could say that was equal to 1/2 x to the third. Now 1/2 is a constant, x is a variable, and it has a whole number exponent. So this one is a monomial. Another new concept is finding the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables in the monomial. So in order to find the sum of the exponents of the variables in a monomial, you take the exponent on each of the variables, add them up, and that's your degree. By the way, a constant has a degree of 0. If it has no variables, then it has no exponents on the variables, which makes its degree 0. In this example, which needs to be in your book, or in your notebook, we want to find the degree of each of these monomials. So we want to find the total of the exponents on the variables in each of these monomials. Now first we have negative 7 x squared y z to the third. In order to find the degree, we simply add up the exponents on the variables only. We don't worry about any exponent on the constant. So on the x squared, our exponent is 2. On the y, our exponent is 1, because we know whenever there's not an exponent up there, it's to the first power. And on the z, our exponent is 3. So if we add up all those exponents, 2 plus 1 plus 3 is 6. So this first one has a degree of 6. In the second example, 8xy squared z, we don't worry about our constant to find the degree. The variable on the x is 1, because there's no, the exponent on the x is 1, because there's no exponent up there, so we have 1. The exponent on the y is 2, and the exponent on z is 1, since there isn't one shown. And when we add all those exponents together, 1 plus 2 plus 1, we get 4. So 8xy squared z has a degree of 4. And finally, 12 squared a b to the third c. We want to find the degree of this. Now notice that 12 has an exponent, but we don't count the exponents on the constants to find the degree. So we just worry about the a, the b, and the c. So a has an exponent of 1, b has an exponent of 3, and c has an exponent of 1. And when we add all those together, we get 5. So the degree of this monomial is 5. When we have more than one monomial combined, we call it a polynomial. A polynomial is a monomial, or the sum or difference of monomials. So a monomial can also be considered a polynomial. If it has two terms, like this one right here, 6x plus 10, it's a binomial, bi meaning 2. And a polynomial with 3 terms, like this one over here, 1, 2, 3, is called a trinomial, tri meaning 3. Now, there are words for more than 3, but after that we usually just call them a polynomial because it's way too much trouble to keep using the prefixes. Alright, so let's look at the parts of a polynomial. First of all, the degree of a polynomial is the degree of the greatest degree term in the polynomial. So in order to find that, you find the degree of each term in the polynomial and then just pick the biggest one. The leading coefficient of a polynomial is the coefficient of the term with the greatest degree, because we always order our polynomials from greatest degree to smallest degree. So the leading coefficient would be the coefficient of the term with the greatest degree. So once you find that degree, you use the coefficient of that term as your leading coefficient. And the standard form of a polynomial is the form of the polynomial where the terms are ordered from the greatest degree to the least degree. So we go in descending order. We start with the biggest degree and we work our way down to the smallest. Alright, so we are going to use this to write polynomials in standard form, and we're going to find their degrees. These examples need to be in your notebook. Okay, so first of all, we have 2n squared plus n third. This is a binomial because it has 2 terms. Now we need to find its degree. The degree of the first term, 2n squared, if we find the sum of the exponents on the variables, would be 2. And the degree on the second term would be, that should be a 2. The degree on the second term would be 3. So the degree of this polynomial is 3 because we simply use the biggest degree. So that would be that one right there. Now we want to put it in standard form. So we're going to start with the term with the highest degree, n to the third power. And after that, we'll use the ones with a lower degree. In this case, a positive 2n squared. And here it is in standard form. In the next example, we have a trinomial. It's got 3 terms, 1, 2, 3. Now, in order to find the degree, we have to find the degree of each term individually. The degree of this term would be 1 plus 2, because the exponent on the x is 1, the y is 2, and 1 plus 2 is 3. So the degree of that term is 3. This term is a constant, so its degree is automatically 0 because it doesn't have any variables. Now this term has a degree of 3 plus 3 plus 1, because that z has that imaginary 1 there. And 3 plus 3 plus 1 is 7. So the degree of this polynomial is 7. And if we want to write this polynomial in standard form, we write it so that we have the term with the greatest degree first, and then we'll work our way down to the smallest. So the term with the greatest degree is 5x cubed y cubed z. After that, we use the next largest, which is this first term, positive 8xy squared. And then after that, we have a negative 9. And this is our polynomial in standard form, highest degree to lowest degree. This last one, to find the degrees, the degree of the first term would be 3, because 2 plus 1 is 3. The degree of the second term would be 4, 2 plus 2 is 4. And the degree of the third term would be 2, because it's a 1 plus 1. So the degree of this polynomial is 4. And if we want to write it in standard form, we're going to write the biggest degree first, which would be negative 3 x squared y squared. Then it would be the next largest, so positive 9 x squared y. And then it would be the smallest, which is negative 5 xy. All right, now let's add and subtract some polynomials. Now, all adding and subtracting polynomials boils down to, like I said, is combining like terms. Now, in this first set of parentheses, I have one polynomial. There's nothing in front of the polynomial, so I don't really need those parentheses. I can just rewrite it like this. And in the second set of parentheses, I have like a positive 1. Now, if I distribute a positive 1 to each of these terms in the second parentheses, it's not going to change anything. 1 times 2x is 2x, 1 times negative x is negative x, etc. So I can really rewrite this one without the parentheses also. And here I simply have an expression where I can combine like terms. So my x squared term is the only x squared term in the expression, so I can't combine it with anything. Let's see, I have x terms right here that I can combine. So I have 3x plus 2x, which would be 5x, minus x, which is 4x. And then I have two constant terms right here. Negative 3 plus 2 is a negative 1. And then this is the simplified form of my original problem. Now let's see how subtraction is different. Again, example needs to be in your notebook. In this first polynomial, I don't have anything outside the polynomial, outside the parentheses, so I can just rewrite it without its parentheses. X squared plus 4x minus 9. Now in the second set of parentheses, I have that invisible 1 out there. So I'm sort of distributing a negative 1 to each term in this set of parentheses. So I have negative 1 times 4x squared. That gives me a negative 4x squared. Then I have negative 1 times negative 5x, which is a positive 5x. And then negative 1 times positive 11, which is negative 11. Once you've distributed the negatives, you can simply combine the like terms. So I have x squared minus 4x squared, negative 3x squared. I have 4x plus 5x, which is 9x. And then I have negative 9 minus 11, and negative 9 minus 11 is negative 20. So there's my simplified form of that problem.